Hello and welcome to our today's event with the topic of off-grid and backup solutions for a future worth living. I am very happy to announce that this event is a joint webinar, a joint event together with DEIF, a very strong partner of ours, of Fronius. And we have the honor to welcome two experts from this Danish company in order to talk about PV Genset solutions. So really some applications in the rural sector. So these two experts, Alan and Jacob, they will introduce themselves in a second. Beforehand, I quickly want to introduce the team at the Fronius end. So I have my colleague Mike behind the camera. He's doing the video equipment check and is also responsible for the chat. So if you have any questions during the session or at the end, you just send it through, just send it in, and then we try to answer them as good and as quick as possible. My name is Chris. I'm happy to guide you through the first part of today's session, and we are both at the team Trainings and Education here in the Solar Energy Department. But now I want to welcome our guests for today. Hello, Jacob. Hello, Alan.
Hello.
Hello. Yeah. Good day and good morning, everyone. My name is Jacob Danielsen. I'm the hybrid product manager here at DEIF. So really very pleased to have the chance to talk about how we merge the product from Fronius and DEIF together.
And I'm Alan Smith, a hybrid application engineer. Have been working in DEIF since 2001 and since 2016 in the hybrid area.
All right.
Thank you.
Thank you for joining us for today's event. I'm very excited to hear your part on this end, to hear about your solutions, your components in order to get such a PV Genset solution up and running. But before we head on into the actual part, into the first part of today's session, I have a question for you guys out there. This question is to be answered in the Menti tool. If you are familiar with it, you can join right away. If not, it's very simple. It's a question and a survey tool, and you simply go to menti.com in your browser and enter this 8-digit code, or you can simply scan the QR code. And I have also prepared a link that you can see now in your chat. You can also click on this and join us. And the question that I want to give to you is, where are you joining us from for today's event? It would be very interesting for us to know. And it's simple to do. You simply pinpoint on the map that you can see right now where you are joining us. So again, just go to menti.com, use the link in the chat, or scan the QR code in order to participate. And I can also already see some reviews. Interesting, very European and Middle East concentrated. UK or even Scotland, I think. Norwegian, Finland, Africa. Perfect. All right. Very interesting. Thank you very much for participating. I will leave this open for now, so you can still join and participate. And I will switch back to the main presentation and proceed. All right. So now the first part, as mentioned, will be a short description or an overview which inverter of Fronius is compatible with our partner from DEIF, and what do we see is a PV Genset solution anyway. Now, one of the first questions would be, of course, who is interested in such a system? And we have positioned here some customer segments, for example, a factory, tourism, like a hotel on an island, mining, and also food processing or agricultural use. So all of these tend to have, in some certain settings, a weak or even no grid connection in some areas. And as you can see, all of these types of customer segments have tendency of a higher load. And in this settings, a generator might be of use. So these customers typically tend to go for such a system. But yeah, what is it actually? How does it work and how is it defined? Now we are always talking of a load. We have heard that already. Quickly turn on the laser pointer to show you. So the load is more or less the defining point. And if we have a grid, that's fine, good for them. But in some areas, it simply doesn't work or it's very weak. And then the genset comes in and is providing and acting as a main or core component. And this one is then contributing and delivering all the loads. Now, what we can do now is also set up a PV Genset solution. So the Fronius inverters contribute into the system and provide a certain amount of energy, green energy, and relieve the amount of the genset's work. And of course, we need some other components, and this is a controller. A controller is very important for safety reasons and also to regulate and control the inverter output power. Because imagine we have no grid, the load is very low currently, but it's a very sunny day and we produce a lot of energy. And if the batteries, which are optional, is full, where do we go with the energy, with the surplus energy, if the grid is not there? It's a very simple solution. We need to regulate the inverter output power down, and this is done by our partners from DEIF, for example. So the solar controller, very important tool in this concept. So we have heard the main task of the PV Genset controller is to protect the diesel generator and to regulate the output power. So we see here a schematic, and it basically shows us a load curve. This would be this gray area. And this load curve will be provided, or this energy under this load curve will be provided by the genset. Now, if we have a solar as well, we see during the sun hours, we produce a lot of energy, of green energy, and support the diesel generator. And this will be then relieved by the dark gray area. So this will be the part that is provided by the Fronius inverters. And we also see a very straight line down below here, which would be a minimum genset load. We do not want the genset to run below that threshold, as it is a very poor efficiency, and we can prevent this by regulating down the output power of the inverter so that it does look like this. So we are following the load curve and we're reducing the output power to a certain limit so that the genset can run on its minimum genset loading. We also see here the inverter power that we use and also the maximum possible inverter power. But as we see in this setting, it does not work because of the minimum genset loading. And we also see the peak load demand at the very top here. So all in all, we know now how it works, how it's defined, which components should be in such a PV Genset solution. And we know also the main task of this controller. Now, the question why? Why would anyone go for such a system? Of course, main task would be a stability of the entire system. As we have mentioned before, if you have a weak or even no grid, you can rely on such systems to provide your loading. And also, it's very easy integration to an existing genset, thanks to DEIF and their flexibility. We see later on how this works. Of course, it's cost effective. We save money by lower energy prices. A certain amount will be produced by our own produced green energy, and we save effectively on fuel expenses. We need less fuel. It also means, because of these things above, that we talk about the rapid amortization. So it is a real business case. And later on, during the end part of the DEIF presentation, we see some real business cases. So it really does make sense to go for such a system. With everything going on right now globally, with climate crisis and all the effects that we see and feel, it's also important to decouple from a fossil fuel dependency and to reduce the carbon footprint. So we must not forget on this topic as well. All right, before we head on into a general overview of which inverters we have ready to use, I quickly want to point out 3 important recommendations when it comes to the design. And the first one we have already heard, it's a minimum genset loading that we do not want to undershoot. For most of the generators, it's about 30% minimum genset loading. Some manufacturers point out something different. And also there are different kind of generators out there. For example, a gas-driven generator tendency has a higher minimum loading of 50 or 60% even. And we need to focus that. We must not forget that. The second point is in combination with the first point, and it is the maximum AC inverter power should not exceed 60 to 70% of the genset power in order to not regulate down unnecessarily. So this means, I give you an example, if we talk about a 500 kilovolt amp genset, we must not have more than 70% of this inverter power. So 70% of 500 would be 350 kilowatt of inverter power would be our limit. This is a rough recommendation we give. And the point number 3 is you can do a DC to AC ratio to the maximum, meaning that every Fronius inverter has the possibility to oversize it. So on a 100 kilowatt inverter, you can put up 150 kilowatt peak on the roof, so solar modules. And this means that you simply have more energy during the day. Also, you might want to think about different orientations to synchronize to your loading. So for example, an east-west installation gives you early in the day and also later in the day more yield. This is also something you can think about when doing the first design. All in all, if you need help, we are here for you. First of all, you can contact your Fronius technical sales advisors, or if you don't have any contacts with Fronius so far, you can go to our homepage and simply contact us. The contact details are there. And of course, I highly recommend getting in touch with the experts from DEIF. Go to their homepage as well and get in touch with them. We together will help to solve your problem or to help you design your systems. All right, before we head on into the next part where I want to show you all the possible inverters that you can use for rural electrifications, I quickly want to jump back to another Menti question. So if you joined just now, go to menti.com, give in the code or scan the QR code and join us for this question. And the second question would be, how many % of your PV installations include generators? So is it something new for you? Have you done it 0 so far? Or 25% of your installations are already with PV Genset solutions? 50, 75, or even 100% is possible here. So thank you for participating. It also helps us getting to know where our attendants, our registrants are in this matter, how well they know the systems. All right, it's all anonymous, no worries. We see that the majority is now voting for none or up to 25%. A few of you guys are a little bit more in detail about these topics. All right. Thank you very much. I will leave it open for now and go back to the presentation. Feel free to vote in the meantime. And now we head on to the Fronius inverter overview. You might know this product. It's an old friend of us and already in the field out there over a decade. It's the Fronius Snap inverter. And yes, it's still a reliable product we offer also for rural electrifications. It's the Fronius Samo Advanced and the Fronius Echo. So you might know there is an additional word in the naming, the advanced. It has all the features than the Fronius Simo, but one, we have an additional arc guard, meaning a DC arc can be detected with this product and the whole system can shut down now. So it's a safety feature that we include in this product. So the Fronius Simo Advanced comes as 3-phase inverter with 2 MPP trackers and 10 to 20 kilowatt power classes. So it's the flexible one, you could say. And then there would also be the Fronius Echo, which is more or less a Fronius Simo, where we put out one print board. Therefore, it's lighter and more cost effective, but we only have 1 MPP tracker and power classes 25 and 27. Of course, you can combine them however you like. We talk a little bit more about that on a later slide as well. So the Fronius Snap Inverter, first of all, is still one choice you can go for when designing your rural electrifications. Now, I'm very happy to announce that there will be a new product in 2024 from Fronius, and it's the so-called Fronius Verto. It's a new design and coming in the power classes 25, 27, 30, and 33.3 kilowatt. So as you see on the power class, it is more meant for the small commercial systems, but as well, of course, for PV Genset solutions with DEIF, for example. This inverter has pre-configured MC4 connectors at the bottom, so you can directly connect your strings to the inverter. And it has also it offers you a high flexibility because of its 4 MPP trackers. So different roof angles, smaller or bigger generator sizes, all possible to connect to one inverter. You see down below the pre-series is already up and running. So in the next few months, we can already say start of sales for the Fronius Verto, and expect some more events, webinars, and trainings on that, of course. All right. We know this one, hopefully already. This one is the Fronius Taro, our biggest commercial inverter yet. It's 50 or 100 kilowatt output power, and we offer it in 2 different options. There is the Fronius Taro with 3 MPP trackers, and there is the Fronius Taro Echo with only 1 MPP tracker. And both of these versions are able to choose as a direct or a pre-combined variant. So a direct Taro has pre-configured MC4 connectors at the bottom. So same as with the Verto, you can directly plug in your strings to it. And the pre-combined is more or less for big cable cross sections on the DC side with internally positioned V-clamps. So if you have a string combiner box out in the field, you simply come with a big cable cross section to the Taro and connect it there on a pre-combined Taro. So this one, of course, is for big commercial systems and also for off-grid solutions. So for everybody who is watching and joining us from the Latin American region, we now are very happy to announce that in Q1 this year, 2024, there will be a Taro, especially for you, available, the Taro Echo 50, 208 volts. So it is a direct or pre-combined as well, and especially for your market, for your voltage range, ready to use. So all the features that we've seen before are also applicable for this product here, just with the difference of the voltage range and the certificate that you can use it in the Latin American region. Now, last but not least, I want to talk about communication interfaces. And you should know that there are different ways how you can connect DEIF and Fronius together. For example, it is possible to use the Modbus RTU connection from Fronius to DEIF directly in order to get the controls, or you can go for a Modbus TCP connection and a standard Ethernet cable. If you do it with the Modbus TCP connection and via Ethernet cable, for example, you can go to a router or a switch directly, and therefore you have 2 things possible. One is the control and the connection to DEIF, and in parallel, you can also go to Fronius Solar.web and use the monitoring platform of ours. So if you go for Modbus TCP, both is possible, no worries. And this goes for the Fronius Verto and the Fronius Taro, as we have here the new pilot card, the new communication card integrated. Now, it looks very similar on the Fronius Snap Inverter range. The only difference is here that there will be products out there with no data manager card integrated. We are talking here about a light version. And this is fine like that because you only need one data manager and can connect multiple inverters to it with a so-called solar net ring. It's a simple in and out connection with a standard Ethernet cable, and you simply go through, connect all of the light versions to one master with the data manager card integrated. And from this one, you can again decide if you want to connect via Modbus RTU or TCP to the DEIF controllers. The only thing you want to watch out for here is that if you go for a Modbus RTU connection from a snap inverter to the DEIF controller, there is no way to include a Fronius smart meter in the same system, as it would also need the Modbus RTU connection. We do not have this problem with the Taro or the Verto, as we have two Modbus connections, and we can use one for DEIF, one for Fronius smart meter. For the snap inverter range, this is not possible. All right. Last but not least, we have one special country setup that we need to select when operating in such a system together with DEIF. And this is called microgrid. The microgrid setting offers us an extended voltage and frequency limit in order to operate in such a system. And on a snap inverter, it's very simple. You just go to the display of the inverter, enter here the access code. It's the same as for starting up the inverter initially. And you enter here MG50 or MG60 for 50 or 60 Hertz microgrid. On the right-hand side, you can see a screenshot for a Tau inverter or a Verto inverter. They both look the same when commissioning. And here you simply select in the installation process 50 Hertz or 60 Hertz microgrid. This is all you need to do. Then the extended voltage and frequency limits are active. All right, so that's it for now for my Fronius part. We are now heading on to our colleagues from DEIF. And before we go there, we have one more Menti question. I'll quickly jump ahead. And the question before we go to this part, of course, would be, do you already have experience with DEIF controllers? A simple yes or no, very helpful again for us, and interesting maybe also for you to know how the audience of this webinar, of this event is voting here. So the majority, it seems, is voting no, no experience yet.
Thank you very much, Christoph. Of course, I wanted the number to be higher, but it will be by the end of the day then.
Hopefully, that's our goal, right?
Yes.
All right, I quickly give you the moderating rights. So we jump back to the Menti question, and now you have full control over the presentation.
Yes. Thank you very much. And first of all, thank you, Christoph, for inviting us to be a part of this. We are very happy with the cooperation for Fronius, and we hope also the audience will see how easy it is to connect the Fronius system together with the DEIF system. 2 seconds. I will just talk a little bit about what we are going through today. I will spend a very short time talking about who DEIF is, and then actually through the agenda, we will actually go from the very simple systems and to a more complex configuration of the system. Here it is important that we talk about brownfield and greenfield, and to make it very simple, you can say then it's actually brownfield is if you are having an existing system where you want to add extra sources. It can be PV, it can be extra gensets, and greenfield is if it's a complete new plant that you are designing and you want to have the full benefit of the new control systems and so on. Then where Christoph he ended was actually the TCP IP part and how to configure. We have a few words on that, and then we have our HMI screen and a little bit about where to find extra information and also the stories at the end. Alan, he will come in and help me after one or two topics here. A little bit about DEIF. We are located in Denmark, so not that far from Fronius in Europe. We are 90 years old last year, so a very old company, privately owned, and our owner, he is still an active part of the board. We are located in many countries all over the world because we also have a history in the marine business. So we are trying to give the best support locally as possible. We are, again, close to 600 people worldwide. It's growing every day. And again, we focus a lot on the present, you can say, energy transition going on in the world. So we also spend a lot of things into development and how to make sure that you as a customer are able to get the best products. The areas where we are operating is marine, but I have focused on the land power here today, and that is the biggest part of DEIF. And here you can see that we are able to mix quite a lot of different assets, energy sources, and actually the platforms that we are going to present today is actually covering a lot of these in total. So if you after this have a project where you want to add gas, just like Christoph he said, or wind, then you might look in the way of DEIF. So let's start with the simple part, and here we have a product. It's called the AGC 150 Hybrid. I actually have a controller here in hand, and the funny thing is that all the slides we are going to show today, and also that the products that you are going to have a name on, is actually working on the same hardware here. We call it the 150 series, and you can actually twist it to be one or the other functionality. I hope it's more clear when we have run through the different parts of the presentation. But let's start with the simple one, where you can say you maybe have a local consumption. It could be a factory like this. Also, Christoph, he showed the different industries using this, but it could be in a very remote area where you have a factory. And here you have traditionally maybe run on diesel gensets and transporting diesel to the site. And now you want to add a PV installation. And I will not repeat what Christoph said, but it is very important not to over-dimension, you can say, the PV part, because that could maybe put the genset in a situation where it's actually, again, not running very optimal, but you could actually even destroy the genset sometimes if you do it in the wrong way. So there is important to have a controller on board. The AGC 150 Hybrid is actually what we call a genset controller, but we have added the PV controls to it. So it is actually able to sit on a genset, be the genset controlling unit, and then communicate to the Fronius inverters and control them according to what Christoph was showing in the beginning. So it is, of course, a controller that's ideal for PV integration with gensets, local consumption, but we also have the possibility to connect own plane of array sensors and backup module sensors, because then we actually can calculate what we can take out of the PV system, of the Fronius system, when we are in the control of it. And we also have a small PLC part inside that can help to do customized functions. It could be a button you want to push, and you can then do special needs and so on. And of course, the minimum genset load is a very important feature we have put in to all of this. One of the things you also get by having a controller from DEIF is actually the three-phase measurements. You get them in two areas, you can say. You can have it from the genset part where you have three-phase voltage and current measurement, and you actually have an extra set of CTs and an extra three-phase set of voltage to actually use that for other purposes like the mains connection and so on. So this is something you get on inside the controller itself, and you don't need to have power meters and other things externally. Also, PV inverter communication is something we touched just a few minutes ago, and here we have actually two ports. With RS485 we have the TCP IP connection, and with this controller we go up to maximum 16 inverters from Fronius to be connected to. We don't focus on the size of the inverters or anything. It's actually 16 of the size you like. And also what you are able to get is actually we are also able to get connect to a grid connection, just like it's shown here on the picture. So it's actually more or less the same setup where one controller is able to control a genset, PV, and also have the mains connection or the grid connection. And we all know that a typically standard Fronius PV system is a current source, so it cannot be the grid forming part. So here, of course, in this situation, if the grid is the grid forming part, we are actually able to start and stop the genset, so we actually reduce further the need of fossil fuels. So, and all of this can be started either by how much we are importing from the mains, but we can also do it based on the PV production, because you could maybe squeeze the PV to a very high level, and then you want to start the genset to support that part. So all of this is automatic. And if some of you are coming from the genset world, you will know quite a few of these standard features like zero mains export, load takeover, fixed power, and so on, automatic mains failure, many rural areas, the grid is not stable, so we can actually take over the load as we see that the mains are failing, or we know that the mains will be disconnected. All of this is inside one controller. And what we also have added, there is a small display on it. Now, of course, here it's black, and there are buttons to push. They are adaptive, so they are turning on and off as they like. But also the ones with a good side can see that we actually in this small display have been successful to put in a lot of details and information about what power is going in and out of the system. So that is also very important. The last part before I leave it to Alan is actually the solar controller, and you will see exactly the same picture because it is the same hardware and software where we have just turned it into another kind of controller. But the picture is the same actually, but here you will see that I have added a gray box near the genset, and that is because maybe it's a brown field. It could be a non-DEIF controller that is put on the genset, and we are also interfacing to that part. So we can interface to different genset controllers, but also if you add a power meter, we can also do it in that way, and then actually the controls are exactly the same. And also here you can say it's the same topics and wording we have here. The only difference there are here is that we allow up to 32 inverters on the same controller. And again, also here, of course, we have the three-phase measurements, so we are also able to do a kind of closed loop control. So if you can say, unfortunate, one of the inverters are not performing as expected, then by broadcasting the power set points and so on, we can increase that so the others will cover what the 1 or 2 inverters are not performing. So that is also a part where we are. And I think actually that is more or less it. Then I will leave it to you, Alan. So, sorry, I have one slide more, and that is actually we can put in multiple gensets as well to this solar controller. So here actually we can do up to and you can see here I have tried to draw that you are connected to the different gray boxes, but we are actually able to connect up to 16 gensets with one controller and up to 32 inverters with the same controller, and then also up to 16 mains. I know talking about rural areas and so on, this is not needed, but just to put in where we have put the limitations. Good. Up to you, Alan.
Thank you, Jakob, for this nice presentation so far. The next thing we'll talk about is actually a quite new thing we have made, which we call DEIF Open PMS. So adding new sources to your hybrid plant. So the idea here is with the Open PMS that you keep the controllers for the existing power sources in your system. So this is also indicated by the gray boxes up here. So actually then the solar and storage will be able to communicate together in a power management fashion or energy management fashion, as you maybe some of you know from before. And it still makes it very easy to add different new power components. In this example, I want to add a solar system from Fronius. We already have the storage system in the application. So simply by adding one new controller, then we can make these two communicate together and you have the full system. You can see I have shown the power meters also mentioned by Jakob. So we need to measure what's happening on the generators, what's happening on the utility still. And you also have the possibility actually for increased functionality to install an AGC mains in your system. So you move closer towards the full power management system. Communication wise, we have an example here of a microgrid. I have 4 generators, 1 generator down here, 3 up here, and then we have the solar and in this case storage systems. So what you can see is, of course, for the communication, we have PV comms. We'll come back to that later a little bit how it works. Of course, we also have the comms for the battery energy storage system in this example. And then we have the blue lines, which is power meter communication. And you can actually do what is easier for you. So if this generator is down here, you can connect it to the first controller. And if these generators sits up here, you can connect them to the second controller. The communication between the controllers will be done in a power management link, an internal power management. So it will either be CAN bus, which is what we traditionally have been using, but actually we also offer the possibility to do power management over Ethernet on these AGC ASC 150 devices. The purpose is, of course, to maximize renewable production with the existing generators. You want to use this system when it's not in your scope to retrofit generator controllers on the existing generators, so you can still get the full benefit of a power management system. You have fuel saving, of course. Then we don't control the start stop of generators, we don't control priorities, things like this, but you still have the fuel saving. And of course we'll run the generators that the system, the PLC system brings online. We'll run them on the minimum genset load in the off-grid applications. So here you still, with the power management of the renewable sources, have the full cooperation for the PV production, charge cycles, discharge cycles, curtailment of the PV. Increased functionality with the AGC mains, as mentioned. You have, for example, AMF mode as a possibility. You have mains breaker synchronizing, some increased Cosmos fee control modes. So it's not a old thing. It's rather new that we have made this, but it's a possibility. The DEIF power management system that you maybe know from before is a flexible microgrid system, again with all the features from the power management. So here it's a new system. If you have the generator controller retrofit possibility, you can use this system as well, and then you get the full power management features. So it's a priority exchange, it's the safety functions, load dependent start and stop functions, of course, splitting reserves. So here again, it's easy to add Fronius to the system here, because the controller is a part of the integrated system. Scalability is very easy with this system. I've just shown for the maximum numbers for the rental customers here, 32 generators as a maximum, and for maybe more critical power, it's 32 mains controllers for the grid tied and grid connected systems. And here, of course, you have protections and breaker controls of all power sources. So it's indeed a full power management system that you get. Communication is more or less the same as before, but of course, all controllers now communicate on the same power management communication. The main purpose, again, maximize renewable production. Since we have the full control of the generators in this setup, we can also offer you the spinning reserve support. It can be the dynamic with the Fronius system, but also fixed spinning reserve if your load demands and load impacts demands this. So we have fuel saving, we have the running hour control, because we control start and stop of generators, and we have a fuel optimizing mode that will rotate the priorities of the generators depending on the load size and the size of the actual generators. And then of course we can stop all generators when it's needed. Then minimum or optimal genset load is a main function. So with this, we can actually offer to use our system in all normal modes for island and parallel applications for backup and commercial and industrial or rural electrification. If you want to go for the power management features, just to note, we have full presentation on the DEIF webinar on DEIF.com. So for more information, that's definitely a good way to go. I will quickly run through now our new communication. This has also been released recently. Before we were more RS-485 compatible controllers, but actually the opportunity with the 150 platform is also to use the TCP function. So I made this example with two systems here. Let's say we have Cymo Advanced, 4 of them, 3 of the light version, 1 of the full version with the data manager card inside. Let's say the IP ends at 54, and on the other building we have a data manager in the first inverter with the IP, say 55. And then how can we set this up? In the DEIF free of charge utility software, we can select the application setting here on the left hand side and go to PV Setup. And what you need to do is actually enable the data manager of the first node here and the data manager of the second node, add the IP addresses, and then TCP type is the control type, add the number of inverters at each node, which was 4 in my example, and then you have more or less set up the communication system for the TCP. So this frees up the RS-485 for other purposes, like we have seen demands where a solar Fronius smart meter should be connected as well to the system. So that was sometimes a conflict. Thank you, Jakob.
Yes. I know you have been focusing and concentrating now for more than 45 minutes, so I will do the last part here quickly, but I hope you can say, be able to keep up 5 minutes more. Also, sometimes at these sites, you would like to have a kind of local display, also showing a little bit more. And here we actually have a standard product. We call it touch display unit, and it can be installed. But one of the nice things is that it's actually a plug and play to the power management system, and you will then be able to monitor everything. So here I have just brought in an example. It's maybe a little more complex, but it is actually a mains and 3 gensets, just like Alan, he showed one of his applications, and a PV connected directly here to the load point and other things, and a battery. And it is actually just to connect, set up again the communication, and then you are able to connect to all the parts in the system. And also very quickly, you can also go into each controller or each asset and then get some information. Here I have an example of a battery. I have an example here where you customize what kind of bar graphs you want to see. And here is a PV example. And the last one is actually that you can go into each of the parameters and configuration. One of the important things also to understand for those of you who have not worked with DEIF before is that there's no programming in our systems. It is that you have a controller for each asset, you put in parameters, and bing, it's up and running. You don't do any software or other things, it's purely configuration. So that is one of the benefits, and you buy a controller for each asset. And some of you might say, oh, that's a lot of controllers. Yes, but it actually also brings safety, and it also brings you, you can say, a fair system, because the 150 series are actually available in a very fair price level compared to other microgrid controllers. Maybe some of you have been a little lost in what is brownfield, what is old, what is new, what is greenfield, and so on. So also at the DEIF.com, we actually have made an application guide where you can go in and understand more of this. And what we have included in this is, of course, to more clearly explain what we mean about greenfield and brownfield, and of course the products, and also how you set up your own application. So Christoph, I think now we have a Menti more.
Exactly. We have one more Menti before we go into the case stories. We quickly change over there. You remember Menti, just go in there. Hope you have left it open on your browser and answer to the following question. It's a word cloud, so the answers will pop up there. Where have you already installed PV Genset systems? You can enter here a country where you have installed some, or an area, a region, a location. Would be just interesting for you, for us to know where you are working or in which areas that you are working in. So let's see what kind of answers we do get here. Pakistan, all right. And a hospital all over Pakistan. Sounds great.
We also see that Pakistan is a very active country in terms of hybrid and so on. It's actually very nice developing.
India, so we are right in this region again. Madagascar, Togo, Lagos, Nigeria. Perfect. Oh, that's great. Tanzania, Dar es Salaam, Montenegro. Okay, nice. Oh, nice. You can post flags too, Turkey.
Great.
All right.
Very nice.
So thank you very much. We will leave it open. So in the background, you just keep posting. Will be interesting for us at the end to check it once more. And I will hand back to you, Jacob, for the final part.
Yeah. The final part I have here is, of course, the case stories, and we will do them quickly so we have a few minutes for questions. I have found a couple of projects here where we, together with Fronius, have installed actually the tower. This is a very remote area, so there's no mains or grid connection here. So it is actually genset, one genset of 500 kilowatt, and then 3 times 100 kilowatt tower. So it actually shows very nicely or clearly the things that Christoph he started to show, where we have a load and we have other things during the day, and the PV is supporting with all possible power that there's to balance, and then of course keep the minimum genset load in different situations. So this is one example, and also just to say that it is actually also shown in different areas where how much fuel we are saving with the different systems. And here you can actually see that on a Brazilian kind of solar channel side. Maybe some of you know this. This case have actually been shown, and the customer have told about how much he have saved about for this system. The next one I have here is actually also in Brazil, but it's a chicken farm, and here we have grid connection, but still one controller, as you can see here. So it is whenever it is one grid connection, X number of PV, and also the one or two, one genset, or maybe even more gensets, we are able to control it. And you can see down here in the pictures that there are the AGC 150 hybrid installed, and you can also see actually opening up the cabinet. And on the PV part, of course, there is the nice Fronius inverters. There's both a tower and an echo installed together with the DEIF controller. And also here you can see that there is an operational mode. It's called AMF. So it actually means that we are detecting if anything happens on the mains, the grid income, and then we will cover so we can prevent blackouts. The last one I have decided to take with me, I saw some of you were putting Madagascar in, but that is actually the Madagascar textile production, where we have 10 Eco 25 kilowatt and 2 gensets. So here, but again, also the guys who know something about gensets will see that it's actually not DEIF controlled gensets. They are from one of our competitors, but here we are connecting on top of the system, and we are actually controlling the PV according to what we know from the gensets. So again, also here a very nice combination. And here you can see that we have installed 2 genset controllers to manage this part. We have more cases you can find also on the web page, and I like that actually Christoph he started to show a nice picture of a sunny island and so on. You can also see that here on our page that there is a Maldives case story. So of course we all would like to go to these places to enjoy, but also happy that we can charge our mobile phones and other things in these rural areas when we are on holiday. But that was all from Alan and I. The picture here is actually showing different platforms or different controllers that we are supplying to the market. The one here below in the picture is actually a PLC. So we also are supplying, you can say, open PLC environments where you can put in whatever you like, but also combine it with our PV hybrid controllers. And yeah, so thank you very much. And I know time is short, but let's do our best to cover some of the questions.
All right, thank you very much for your part. And yeah, as you mentioned, now would be the time for a quick Q&A session. And I've got Mike here on my side, and he wrote down a few questions that we got in the meantime, and also some frequently asked questions that we now want to go through.
Yeah.
Do you want to go started with the first one?
For sure. So thank you for the lots of questions that we received during the webinar. So let's start right away with the first question, and this is about the size of the PV generator and the genset solution. So how big needs to be the PV generator in comparison to the genset solution, Christoph?
All right, you might remember the one slide where we talked about 30% minimum genset loading, 70%, some recommendations. So this would actually mean, or this is actually the sizing that we need to focus on. So keep in mind the minimum genset loading and don't go above 70% in comparison to this. So the genset always should be bigger than the inverter size, and then you're good, basically. Then you don't need so much regulation of the inverter output power. And maybe also in part of this question, remember also the compatible inverters for this. We have the Taro, as we see behind us, the Verto coming in as a new product this year, and also the Snap Inverter series with the Simo and the Echo.
Mm-hmm. That's a good sign, yeah. Then I have one question for Alan, please. Please explain the difference in the variants of the ASC 150 and AGC 150H. So what really are the differences, one customer wants to know?
Yeah, the AGC 150H or AGC 150 hybrid, this is actually a generator controller. So very often it's installed on the generator, taking care of the normal generator part, start, stop, synchronizing, and generator protection. But then we have added the possibility to also control PV inverters with this generator controller. Whereas to compare with the ASC, which is the solar controller, a straight solar controller, which only takes care of this part, there we rely on communication to third-party generator controllers or to power meters to know what is actually happening on the generator plant. So one thing, it's a generator controller with solar output, you can say, or the other one is a solar controller directly.
Mm-hmm.
So it
very well.
Application that you want.
Perfect. So talking about the ASC4 maybe as well, when do I need to use the ASC4 that I have used previously? That was the question.
Yeah, ASC4 was our good old product. It's still in our product portfolio, and we sell it together with the ASC 150. Where you have higher demands for safety, like double canal lines, you have double redundancy demands, or even if you have demands for short-term weather forecast systems, then you would want to go to the ASC4.
Mm-hmm. Perfect thing. Then another question about the Open PMS configuration. How do the generators start and stop in the Open PMS configuration? How is that possible?
Yeah, it is actually possible in different ways from our controller. That's typically the case when you have storage system integrated. Like you can run the storage system in different ways, but like if it's SOC based, then when the SOC of the battery comes down to a lower level, we'll simply draw a relay, pull a relay in the DEIF controller, and this would then go to the PLC system or the third-party power management system, and then it's basically up to the PLC integrator or the third-party system to start the correct number of generators and so on.
Mm-hmm. That's a very good point. And another thing about the Open PMS, which generator controllers and power meters are actually supported using the Open PMS?
Yeah.
On our DEIF webpage, under each of the products you have seen here, there is actually documentation, and there is an application guide or a compatibility list. And here you can actually go in and see all the power meters and genset controllers that we are able to communicate with. And I would also open up for, if there is a customer having a special need, we can definitely look into that and maybe develop the new communication to that specific part.
Very well, thank you so much. And one last question I want to mention here is, one customer wanted to know where he can meet us at the trade shows in 2024. So where are you guys at the trade shows?
We are actually in many different trade shows all over the world, so to speak. But we can say where we know Fronius will also be is, of course, the Intersolar in Munich. Then we have Solar Pakistan, we have Ampere in the Czech Republic, and then of course Solar and Storage in Mexico. That could be 4 examples, just to mention worldwide some examples.
But we also have a list on our webpage where you can find all the trade shows where we are participating, and it is nicely spread all over the world. So hopefully you won't travel too far. Now in these green times, you don't need to travel that far. So maybe look at that list and see where you can find us. And I believe you, Fronius, you have the same, where you can.
Exactly. So thank you for pointing over. So we do the same thing. We are on globally seen on a few trade shows, and just check out our homepage where we are next. And as Alan and Jacob already mentioned, there are a few where we are both represented, DEIF and Fronius, and then we can help you out here. So I think we can leave it at that point. We have lots more questions coming in the meantime, so don't leave now. We will text you back. Jacob, Alan, Michael, and me, we will stay online. We just turn off microphone and camera in a second, and then we will write you back to your questions, and also later on during the next 2 days. One more question, which is organizational, I want to mention right away. There was a question, can I get the video afterwards? Yes, the video will be sent out to everyone who registered to this event in the next 2 days. So they will be automatically sent out, and you can rewatch it as many times as you want. And you will also be able to find this video in the next 2 days on YouTube on our channel as well. All right, and one last side note to you guys, the colleagues from DEIF. I have seen there is a request for a comprehensive video on DEIF configuration. So it looks like the next video is already in the queue.
Yeah, it looks like it.
Yeah. Thank you for that.
All right. So thank you very much to Michael, to Alan, to Jacob, to you guys out there watching. Have a nice day. Have good installations, and hope to see you soon.
Thank you.
Thank you.